March 2, 1943, the Bismarck Sea, north of New Guinea. Dawn breaks over calm waters as a Japanese convoy of 8 transports and 8 destroyers plows southward. The ships carry nearly 7,000 troops, reinforcements deemed essential for holding the strategic base at Lai. On their bridges, officers scan the skies with confidence. Naval doctrine dictates that dispersed vessels with anti-aircraft coverage should survive air attack. Intelligence reports suggest American bombers rarely score better than 1% hits against moving ships. But aboard a B-25 Mitchell at an Australian airfield, ground crews load delayed fuse bombs while armorers check 8 forward-firing .50 caliber machine guns, a modification never envisioned by the aircraft's designers. In the operations room, a simple doctrine takes shape: attack at wave-top height, suppress deck gunners, and skip bombs into ships' hulls like stones across water. The Imperial Japanese Navy was about to face a revolution in aerial warfare. March 1943, Townsville, Australia, 5th Air Force Headquarters. A wall chart displays a stark statistic: approximately 1% bomb hits against maneuvering ships at medium altitude. Major General George C. Kenney studies the numbers with growing frustration. Pre-war bombing doctrine has proven inadequate against moving naval targets. The assumptions of precision daylight bombing from 5,000 to 10,000 feet, carefully calculated in peacetime, are failing in the Southwest Pacific area. "We need a better way to sink ships," Kenney tells his staff. "We need to get lower." Between June and October 1942, 5th Air Force crews experimented with alternative approaches. Captain Kenneth McCullough and others tested the first low-level attacks with standard B-17 Flying Fortresses, aircraft never designed for such missions. The bombers approached at wave-top height, releasing bombs with delayed fuses to skip across water into ship hulls. 5th Air Force operation summaries document these early trials. In one test near a coral reef, observers timed the skips and underwater trajectories of practice bombs. The numbers told a compelling story. Lower altitude vastly improved accuracy against ship-sized targets, but crews faced intense danger during the straight-line approach run. By October 1942, low-level trials showed promise if crews could survive the withering anti-aircraft fire during the attack. November 1942, Eagle Farm Airfield, Brisbane, Australia. A B-25 Mitchell bomber sits on maintenance stands, its glazed nose removed and discarded on the tarmac. Around it, mechanics and armorers work with urgency, positioning heavy Browning .50 caliber machine guns in a new solid nose assembly. This workshop belongs to the domain of Paul Pappy Gunn, former Navy pilot, airline engineer, and now 5th Air Force's chief improviser. At 53, the white-haired Gunn approaches aircraft, modification with a mechanic's pragmatism and a fighter pilot's aggression. General Kenney had given Gunn simple instructions: pull the bombardier and everything else out of the nose of the B-25 and fill it full of .50s. The B-25. Mitchell was designed as a medium bomber with a glazed nose for a bombardier operating a precision bomb sight. Gunn and Kenney reimagined it as a gunship for mast-height attacks, a commerce destroyer that could survive the dangerous final approach to the target. Jack Fox, North American Aviation's liaison officer, watches with professional interest as Gunn's team transforms the aircraft. The modifications violate the manufacturer's design specifications but promise deadly effectiveness. Beyond the 8 guns in the solid nose, Gunn's team adds cheek packs with additional machine guns. The ventral turret is removed from many aircraft to reduce weight and drag, increasing range. The top turret is modified to lock forward during attack runs, adding more firepower to the frontal barrage. The concept is simple but revolutionary. Turn the most dangerous seconds of the attack, the straight bomb run, into an offensive window where overwhelming forward firepower suppresses anti-aircraft gunners. By February 1943, a squadron of Strafer-equipped B-25s is operational, waiting for the opportunity to prove the concept against real targets. December 1942 to February 1943. Training fields across Australia and test ranges at Eglin Field back in the United States. Crews learn a new attack profile that contradicts everything they were taught about bombing. On range boards, instructors diagram the approach, maintain 200 to 275 miles per hour at altitudes between 250 feet above water, release bombs approximately 300 yards from the target, set fuses for 4 to 5 second delays to detonate alongside or under the ship's keel. The geometry is precise and unforgiving, too high or too fast. The bomb skips over the target. Too low or too slow, the aircraft risks hitting the water or becoming an easy target. Released too early, the bomb skips harmlessly past. Too late, no time for the bomb to properly position before detonation. Training films freeze-frame the critical moment when a bomb makes its first skip, showing how it ricochets upward to strike a ship's hull at or below the waterline. The innovation addresses a critical problem. Torpedoes, the traditional anti-shipping weapon, are scarce and unreliable in the Southwest Pacific theater. But with correct delay settings, general-purpose bombs can replicate a torpedo's devastating underwater effect against a ship's hull. Army Air Force's Proving Ground Command standardizes the technique in technical circulars titled Minimum Altitude Attack of Waterborne Surface Vessels. What began as a field expedient becomes repeatable tradecraft across multiple units. By late February 1943, 5th Air Force reconnaissance aircraft report a major Japanese convoy forming at Rabaul, New Britain. The innovative attack method is about to face its first major test against a heavily defended enemy formation. February 28th to March 1st, 1943. Rabaul Harbor, New Britain. Japanese troops of the 18th Army under Lieutenant General Hatazo Adachi file aboard 8 transport ships. The vessels will carry approximately 6,900 soldiers, their weapons, ammunition, and supplies. Reinforcements considered essential for holding the strategic base at Lae on New Guinea's northern coast. Rear Admiral Masatomi Kimura reviews the escort assignments, 8 destroyers to screen the transports. Intelligence reports suggest the escort should be adequate against expected Allied air opposition. The convoy plans to sail along New Britain's north coast, using nighttime movement and weather fronts for concealment. Japanese planners expect their combination of timing, weather, and escort strength to protect the movement. What they don't know is that Allied codebreakers have already intercepted and decrypted messages about Operation 81, the designation for this reinforcement mission. At 1500 hours on March 1st, a B-24 Liberator reconnaissance aircraft radios contact with the convoy. The message triggers a cascade of strike orders across 5th Air Force and Royal Australian Air Force units. Allied planners build a layered attack schedule. First, medium-altitude bombers will break up the convoy's tight formation. Then, low-flying aircraft with forward guns will suppress anti-aircraft defenses. Finally, the modified B-25 strafers will deliver the killing blows at mast height. As night falls on March 1st, the weather begins to clear. At Australian airfields, ground crews load bombs and fuel aircraft. Dawn will bring the first hammer blow against the Japanese convoy, March 2, 1943, the Bismarck Sea, north of New Guinea. Morning sunlight glints off the metal skin of B-17 flying fortresses as they approach the Japanese convoy from medium altitude, 5,000 to 7,000 feet above the water. Below, Japanese ships turn sharply in evasive maneuvers. Anti-aircraft guns fill the sky with black puffs of flak. The convoy is designed to maintain a tight box formation, maximizing overlapping anti-aircraft coverage. But as bombs fall around the vessels, captains instinctively break formation to avoid hits, fragmenting their mutual protection. Squadrons of the 43rd Bombardment Group press home their attacks, while P-38 Lightning fighters from the 9th Fighter Squadron provide overhead cover against any Japanese aircraft that might appear. Although few direct hits are scored, the medium-altitude bombing achieves its primary purpose, breaking up the tight convoy formation. The transport ship Kyokusei Maru takes critical damage and begins to sink. Several destroyers detach to rescue survivors and land them at Lai, further thinning the convoy's protective screen. By day's end, the Japanese ships are no longer in their planned defensive formation. The gaps between vessels have widened, creating windows of opportunity for the low-level attackers scheduled for the following day. As darkness falls, operation summaries credit the medium-altitude attacks with successfully dispersing the convoy prior to the planned low-level strikes. The AA Broom is ready for its dawn sweep. March 3, 1943. Dawn breaks over the Bismarck Sea east of New Guinea's Huon Peninsula. Bristol Beaufighter aircraft of Royal Australian Air Force No. 30 Squadron line up off the bows of Japanese ships. The heavy fighters come in just above the wave tops, their 4 20mm cannons and 6.303 caliber machine guns blazing. Australian cameraman Damien Parer films from an accompanying aircraft for the newsreel that will later be titled Bismarck Convoy Smashed. Japanese naval gunners, trained to expect torpedoes from low-flying aircraft, instead face a hail of cannon and machine gun fire directed at bridges and gun positions seconds before the bombers arrive. This is the AA Broom, an aerial suppression technique designed to momentarily silence anti-aircraft guns during the crucial bombing approach. The Beaufighters target bridges to disrupt command and control, neutralize anti-aircraft positions, and start deck fires that mark targets for following bomber waves. Royal Australian Air Force accounts document No. 30 Squadron as the opening suppression element on March 3rd, with multiple passes against different ships to prepare for the B-25 strafers. The effect is immediate. The density of anti-aircraft fire drops dramatically during the crucial period when bombers must fly straight and level to deliver their skip bombs accurately. With decks swept by cannon fire, the stage is set for the modified B-25 strafers to begin their mast-height attack runs. March 3, 1943. Multiple attack tracks across the dispersed convoy in the Bismarck Sea. B-25 Mitchells of the 38th Bombardment Group, 71st and 405th Bombardment Squadrons, and 3rd Attack Group cross the wave tops at approximately 230 to 270 knots. Major Eugene Mussett leads elements of the 71st Bombardment Squadron, while Lieutenant Colonel Millard Lewis directs the 405th. Their aircraft approach from multiple directions to divide the remaining Japanese anti-aircraft fire. Japanese gunners had calculated their defensive envelopes based on conventional bombing approaches at higher altitudes. The B-25s now attack beneath those assumptions, often no higher than 50 feet above the water. The modified bombers present an intimidating profile. Solid noses with 8 forward-firing .50 caliber machine guns, plus additional cheek-pack guns and top turrets locked to fire forward during the attack run. This concentrated firepower, up to 14 forward-firing heavy machine guns per aircraft, suppresses deck gunners in the critical seconds before bomb release. Pilots follow their technique cards precisely, maintain 200 to 250 feet altitude, release bombs approximately 300 yards, abeam the target, with delayed fuses timed to detonate at or below the waterline. Each aircraft drops its bombs in the first pass, employing either skip bombing, where bombs bounce across water into the hull, or direct mast height delivery. The 4 to 5 second delay fuses allow bombs to detonate underwater against ships' hulls, maximizing damage below the waterline where vessels are most vulnerable. By compressing the approach altitude and combining strafing with skip bombing, Fifth Air Force has dramatically raised the hit probability while shortening exposure time to enemy fire. Fires spread across multiple vessels. Transport ships begin to sink, and now escorts are taking fatal hits as well. Evening of March 3rd through March 4th, 1943. The Bismarck Sea and Vitiaz Strait. Burning and sinking wrecks drift in the once peaceful waters. Follow-up attacks strike rafts and barges, attempting to ferry survivors and salvaged cargo toward New Guinea's shore. From the advanced echelon of 5th Air Force Headquarters, Major General Ennis Whitehead directs continuing strikes against the scattered remnants of the convoy. Australian patrols on Goodenough Island report Japanese survivors reaching shore, many of whom will die from wounds, exposure, or lack of supplies. Japanese planners had anticipated some losses in their high-risk reinforcement operation. Perhaps 1 or 2 ships might be sunk. Instead, they face annihilation. The final tally, confirmed in post-war reconciliations, all 8 transport ships and 4 destroyers sunk. Only approximately 1,200 of the original 6,900 troops reach Lae, most with only personal weapons. Nearly all heavy equipment, vehicles, artillery, ammunition, and supplies are lost. Early victory claims are adjusted downward for accuracy after the battle, but even the conservative confirmed numbers represent a decisive victory. 5th Air Force analysts compare gun camera footage with reconnaissance photographs to verify sinkings and avoid double counting. The immediate strategic effect is clear. Japan's plan to reinforce Lae has catastrophically failed. The tempo of Allied interdiction operations rises across New Guinea as Japanese commanders scramble to devise alternative supply routes. In Tokyo, Imperial General Headquarters orders a complete logistics redesign for New Guinea routes, abandoning large daylight convoy operations in waters within Allied air range. March and April 1943, Southwest Pacific Area Headquarters and airfields. Intelligence officers review strike film frames, carefully annotating release distances and impact points from successful attacks. The analysis reveals a counterintuitive truth. Despite conventional wisdom that medium bombers cannot survive straight attack runs against defended ships, the data show that survivability actually increases when aircraft combine forward guns for suppression with shortened approach distances. 5th Air Force analysts, Royal Australian Air Force observers, and General Kenny's staff compile comprehensive assessments of the new technique. The verdict is unanimous. The combination of tactics, modified airframes, and specialized training has created a reliable anti-shipping capability that can operate without scarce torpedo bombers. Technical summaries identify 3 key components of success. First, the solid 8 gun noses and additional forward-firing armament effectively suppress deck gunners. Second, the standardized 4 to 5 second fuses ensure underwater detonation against ship hulls. Third, the timing between Beaufighter suppression passes and B-25 attack runs minimizes defensive fire during the critical approach phase. This tactics airframe training triad has proven itself in combat. The next logical step is to move from field modification to factory standard, scaling up a successful improvisation into institutional capability. Mid to late 1943, aircraft factories in the United States and modification depots in the Southwest Pacific. A factory new B-25J with a solid nose taxis past crates of standardized strafer conversion kits destined for theater modification centers. What began as ad hoc conversions in Australian workshops has evolved into a standardized production model. North American aviation engineers working with United States Army Air Force's Materiel Command formalized the strafer configuration that Pappy Gunn pioneered. The contrast is striking. What was expected to remain a local field modification has instead become institutionalized, with heavy forward gun concentrations becoming standard across the B-25 fleet. Later production models feature factory-installed solid noses with 8 guns, improved blast tubes to manage gun gases, optimized armor placement to protect critical systems, and increased range from the aerodynamic improvements and weight reductions. Museum collections and technical summaries document the progression of factory strafer configurations and the increasing forward fire counts on late B-25 variants. What began as Kenny's directive to fill the nose full of .50s has evolved into a standard production variant optimized for low-level attack. The capability scales across groups and missions throughout the Pacific Theater. The same choreography of suppression and skip bombing appears in subsequent operations against Japanese shipping and installations at Wewak and other targets along the New Guinea coast. Spring and summer 1943. Japanese headquarters along New Guinea's northern coast. Staff officers review convoy routing restrictions. Daylight movement toward Lae is now prohibited. Emphasis shifts to night convoys, coastal barge traffic, and increased aerial transport using Mitsubishi G4M Betty bombers as improvised cargo aircraft. Japanese planners had initially believed that adding more escort vessels would restore convoy safety. Geographic constraints and expanding Allied air coverage keep the risk unacceptably high, regardless of escort strength. Allied intelligence summaries track the shift in Japanese logistics patterns. Reports note increased barge traffic along the coast, more dispersed loads, and altered routing to minimize time in open water. The cost and efficiency is enormous. Throughput of troops and supplies to forward bases drops significantly compared to pre-March plans. Contemporary Allied reports confirm that no further large daylight reinforcement convoys attempt to reach Lae after March 1943. The logistics calculation has fundamentally changed. As the cost of supplying forward bases increases, Japanese defensive positions become increasingly vulnerable. Allied ground offensives advance steadily along the Huon Peninsula, supported by the same air units that demonstrated their deadly effectiveness in the Bismarck Sea. At 5th Air Force Headquarters, staff officers codify the lessons learned into training circulars and doctrinal publications. What began as improvisation has become standard procedure. Late 1943, 5th Air Force Headquarters. A wall chart compares pre-1943 anti-shipping attack success rates to post-Bismarck Sea operations. The contrast is stark, from approximately 1% hits with conventional medium-altitude bombing to consistent success with the new low-level techniques. What had initially appeared to be a critical liability, the scarcity of aerial torpedoes in the Southwest Pacific, forced the development of an alternative that turned conventional general-purpose bombs into reliable ship killers at short range. 5th Air Force statisticians compile the final numbers, while Army Air Force's reviewers adjust early overclaims to confirmed totals. The process is methodical and deliberate, ensuring accurate historical records. Throughout the theater, standardized approach cards are distributed to units specifying the critical parameters: speed and altitude windows, release distances, and fuse delay settings. What began as improvisation is now standard operating procedure. The Bismarck Sea action demonstrates a powerful principle of economy of force. Properly modified medium bombers with concentrated forward guns, specialized training, and standardized procedures can destroy heavily defended convoys without purpose-built torpedo bombers. The lesson extends beyond the specific aircraft and tactics to a broader mindset. Adaptation, standardization, and aggressive execution can transform existing platforms to meet emerging challenges. Post-1945. A conceptual lineage connects the B-25 strafers of 1943 to later gunship developments. Training materials place technique cards from Bismarck Sea operations alongside schematics for post-war gunships like the AC-47 and AC-130. The missions and technologies differ dramatically, but the core principle remains the same: adapt the platform, codify the tactic, and train crews to operate in envelopes the enemy has discounted or left undefended. In retrospectives, Kenny's directive to fill bomber noses with forward-firing guns is cited as the conceptual spark for the commerce destroyer that proved so effective against Japanese shipping. The Bismarck Sea operation demonstrated how quickly procedure combined with hardware modification could redraw a strategic map. In just 48 hours, a technique proven in training transformed the logistic situation along New Guinea's northern coast. After the Bismarck Sea, Imperial Japan did not again attempt a large daylight reinforcement convoy into the deadly funnel between New Britain and New Guinea, where Allied air power could be concentrated. The operation's outcome was decisive. 8 transport ships and 4 destroyers sunk. Only approximately 1 to 200 of 6,900 troops reached their destination at Lae. The method was revolutionary: mast height and skip bombing attacks conducted at 200 to 275 miles per hour and altitudes between 250 feet, using bombs with 4 to 5 second delay fuses, while forward guns suppressed anti-aircraft positions and bridges. The enabler was a modified airframe. Pappy Gunn's B-25 conversions under General Kenny's direction made the geometry survivable and repeatable for average combat crews, not just exceptional pilots. The strategic effect resonated throughout the theater. Japan ceased daylight convoy reinforcement to Lae, and Allied interdiction operations intensified across New Guinea as Japanese logistics became increasingly vulnerable. Procedure, hardware, and timing turned a medium bomber into a ship killer and changed the convoy war off New Guinea in March 1943. If you value fact-based history, consider supporting the channel. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.